Click. Yeah. What we're going to do today is a revision, actually, something we've done in the past. We just want to look at it again today and see some graph plotting. Today we're going to look at again quadratic. Come on, don't start that. Quadratic equations, yeah? The pen here. Quadratic equations. No, so still forget to do this. Revisit. Let me put it here. Revisit. We are revisiting quadratic equations today. Is it clear? Is it writing? When you have an equation, ax squared plus bx plus c equals 0. This is a quadratic equation because the highest power, where a is greater than is where a, sorry, what it is, okay, one. Where a is not equal to 0. Any other thing else apart of a and x squared, any other thing else could be 0. So even if you have something like this, ax squared equal to 0, still a quadratic equation. If you have ax squared plus b, it's still a quadratic equation, as long as the highest power of the unknown here is x, where a and b are numbers. A and b, a, b, c, these are numbers. Yeah, these are constants. So we did say that if you want to factorize this quadratic equation using the formula method, the factor method, sorry, you can be able to factorize it as a into x minus h squared plus k you can't be able to factorize it this way. Yeah, let me write it properly. You can factorize this a x minus h. Oh my god, you know, this, I think I need to change this letter. A outside into x minus h all squared plus k. This equation can transform into this way. So now, let's say you are given a quadratic equation like this. But before that, let me explain. This a I did mention here that a must not be equal to 0. This a has two functions to play in the quadratic equation. Whatever number you have before the x squared, we call this the coefficient of x squared. A is the coefficient of x squared. B is the coefficient of x, and this is a constant c. This number here, the a, what does it do to the quadratic equation? Quadratic equation, they go into two forms. I'm sorry, my table here is tight, and even I can draw the line here. Let me just leave it this way. Let me try to draw. Let me leave it like this. Don't cause trouble here. Oh yeah. Okay, let me just, you have a graph like this. When you are plotting a quadratic equation graph, you go like this. This is your y-axis, and this is your x-axis. They usually go this way, or you have your y-axis, or they go this way, y and x. So if it goes this way here, it opens downwards. It goes to a maximum point. It opens downwards. It means the a is positive. Sorry, it means the a is negative when it opens downwards. If it opens upwards, it means for this one here, a, it means a is less than 0. I keep a is less than 0. For this one, it means a is greater than 0. When you have minus sign here, this is minus sign, the graph goes this way. If you have, like this one is a plus sign, it goes like this. It means a is positive, it opens upwards. If it is negative, it opens downwards. That is the one function that the a here plays. The other function is it has the ability to shrink or expand the way this graph opens at the bottom or at the top. If this number is big, it's gonna shrink it like this. Shrink the graph. The bigger this number becomes, the smaller this graph becomes. If this number is negative, yeah, and you're getting bigger numbers here, it's going to shrink it like this. Keep shrinking it. So those are the functions of the a at the front of the x squared. Now let's solve a real problem and see. Quadratic equations revisits. Yeah. Let's say you have x squared plus minus 5x plus 6 equals 0. And now we want to factorize this equation using the vertex form. VERTEX, vertex form of factorization. So what do you do if you want to factor this one? One way of doing it is x minus 2 x minus 3 equals 0. Yeah, now you factorize it. But want to factorize it using the vertex form. So by doing that, you say x squared minus 5x, then you take half of the coefficient of x and add it to the equation, which is 5 all over 2. You square it and add it to the equation. But then you have 6 here. It was 6. Then you put your plus 6. But because you've added something here that was not here initially, this 5 over 2 x squared, you have to subtract it again. 5 all over 2 all raised to the power of 2. So this is factorization by the vertex form, what we have done here. We've done this in previous videos. I just want to show you a program here, a plotter, how these graphs are plotted using the software. Okay, so now this will now become 5 minus x minus 5 all over 2 all squared plus 6. Now this 5 all over 2 all squared covers from here to here. This we manipulated this to make this equation conform to this vertex form. So now you have 6 minus 5 all over 2 squared, which is 25 all over 4. 5 squared is 25, 2 squared is 4, 5 over 24. So you still have your x minus 5 all over 2 squared. So this now will become 24 minus 25. You get minus 1/4. So this is factorization using the vertex form. What that means, your 5 all over 2 here now, you know you have minus h now equals minus 5 all over 2. Therefore, the minuses will cancel. You will have here h equals 5 all over 2, which is 2.5. And now this one here, you have k equals minus 1/4, which is 0.25. When you factorize using the vertex form, you get something like this: x squared x plus k. This is the formula, yeah, vertex form. So this is what we have done here. So now we have k equals minus 1/4. So this k here equals to now minus 1/4 for this equation. And this h inside here, so this h is positive. We have it 2.5. 2.5. So 2.5 minus 1/4. Now let's plot this graph and see. So this is the graph. This is the graph y equals x squared minus 5x plus 6. When you plot it, you get something like this. So that's h, which we got as the roots are the roots of this equation, minus 2 and 3. Yeah, let me just expand it a little bit. So this is 1, 0, 1, 2, 3, 4, 5. So 0, 1, minus 2, sorry, 2 and 3. So where is our h here? Our h on the vertex, which was 2.5, is here. This is 1, 2, and you see this, fine, you see it, 2.5. This one here is 2.5 for the height, for the x value, and minus 0.25 for the k, that is the h value, this one here. So that's the advantage or the benefit you get when you use the vertex form to find your roots of the equation. You can straight away read this value. This value is down here. See that? This is 1, 2. This is 2, the root of the equation, and 3. So this h is 2.5. Is 2 and 3 in the middle. And the height, that is this height, this thing here, is on the negative y-axis. Is minus 0.25. So now let's do something. Let's add something here. We'll multiply now this x squared by 2. You see, it shrinks. The equation shrinks. I increase it 3. See that? Increase it 4. Shrinks. So now let us make it negative. Let me reduce the graph. You see that? The graph turns upside down. Now it opens at the bottom. It now has a maximum turning point. So let me add 2 to this negative. Graph shrinks. Let me change it to 3. Continue to shrink. Let me change it to 4. Keep on shrinking. Let me change it to 5. See what is happening? 6. See what is happening? 7. See what is happening? So this is what happens. So now let's try a different graph. Let's say y equals x wow. No, that doesn't work. Let me bring it back. Let me bring back what I've done. Oh. Why is not writing? Hold on for me. Let me take it. Y equals x squared minus, let's say now, this time plus it's x minus 20. Let me reduce it. See that? Let me put minus here. Turns upside down. Okay? So let's put which one when you add make 10 when you multiply b minus 20 1 5. This is 1 5 plus 4. So you get see that? So I hope you enjoyed this lesson. Yeah? Thanks for watching, yeah? Thanks for watching then. Bye bye for now. Bye.